Good morning. Today we are going to learn the most important theorem, that is Pythagoras theorem. Pythagoras theorem. Statement of this theorem is statement in a right angle triangle the square of the hypotenuse is equal to the sum of the squares of remaining two sides. This statement you already know, but we'll prove this theorem in this year. It is Pythagoras theorem. First step is to prove this theorem is to draw proper diagram. Means we have to draw one right angle triangle here. I'm going to draw one right angle triangle, that is triangle ABC. Now here is your triangle ABC, triangle ABC, which is right angled at point B. Triangle ABC is right angled at point B. Now this is our diagram, and we'll draw one more here, that is we'll draw altitude on hypotenuse, that is BD, or perpendicular from point B on its opposite vertex, or on hypotenuse from its opposite vertex. It is BD is perpendicular to AC. BD is perpendicular to AC. Now this is our first step, that is a proper diagram. Now next step is to write given. Now what is given in this diagram? That is in triangle ABC, major angle ABC is equal to 90 degree. Means triangle ABC is right angle triangle, and segment BD is perpendicular to hypotenuse AC. Segment BD is perpendicular to hypotenuse or segment AC or side AC. This is given. See once again, in triangle ABC, measure of angle ABC is 90 degree. Means triangle ABC is right angle triangle, and segment BD is perpendicular to hypotenuse AC. Now what is to prove? It is most important. What is to prove? Then the square of the hypotenuse, and hypotenuse is nothing but side opposite to perpendicular, that is AC, or AC square is equal to sum of squares of remaining two sides. Sum of squares of remaining two sides, and remaining two sides are AB and BC. Therefore I can write sum of squares of remaining two sides means AB square plus BC square. AB square plus BC square. I am going to write this segment BD perpendicular to hypotenuse AC in construction, not in a given. I'm writing it in construction. It is draw segment BD. Draw segment BD perpendicular to segment or hypotenuse AC. Perpendicular to hypotenuse AC. This is our construction. BD is perpendicular to hypotenuse AC. To prove this, we have constructed this segment BD. Now next step is proof. Proof is very simple. Observe, this triangle ABC is a right angle triangle at B, and there is segment BD, or there is one altitude drawn on hypotenuse, that is BD is perpendicular to AC. By using previously proved theorem, that is about similarity in right angle triangle, if the altitude is drawn on hypotenuse, then the two triangles formed are similar to the original triangle and similar with each other. Means triangle ADB, this one will be similar to triangle BDC, will be similar to triangle ABC. All these three triangles formed are similar with each other. Means I can write by using that theorem, theorem on similarity in right angle triangle. I can write triangle ABC is similar to triangle ADB is similar to triangle BDC. All these three triangles are similar with each other. See once again, if the altitude is drawn on hypotenuse, then the two triangles formed are similar to the original triangle and similar with each other. Means all these three triangles are similar with each other. Now out of these three triangles, we will choose two triangles at a time. We will take this pair first, that is triangle ABC is similar to triangle ADB. Triangle ABC is similar to triangle ADB. ABC is similar to triangle ADB. By taking this pair, I can write their corresponding sides in proportion. That is AB upon AD is equal to BC upon DB is equal to AC upon AB. These will be corresponding sides of similar triangles. That is CSST. AB upon AD is equal to BC upon DB is equal to AC upon AB. Now out of these three ratios, we will choose only two ratios containing one side is common. One side is common, that is AB is here and AB is here also. So I am going to write these two ratios again, that is first and third. Since both ratios are having AB as common and we want AB square. We want AB square. Therefore, writing these two ratios again, AB upon AD is equal to AC upon AB. Now, by cross multiplication, we will get AB into AB, that is AB square is equal to AD into AC. AD into AC. That is statement number 1. We will get AB square is equal to AD into AC. Means we got AB square here. Now we will get BC square. And to get BC square, we will take this pair, that is triangle ABC similar to triangle BDC. Now triangle ABC is similar to triangle BDC. ABC is similar to triangle BDC. Hence the corresponding sides are in proportion. Reason is CSST. Now corresponding sides are AB upon BD. AB upon BD is equal to BC upon DC is equal to AC upon BC. Now again, out of these three ratios, we will choose two ratios containing one side as common, and that is nothing but BC. Means taking these two ratios together, BC upon DC is equal to AC upon BC. BC upon DC is equal to AC upon BC. Again, by cross multiplication, we will get BC into BC, that is BC square. BC square is equal to AC into DC or DC into AC. Suppose statement number 2. Now, we got statement number 1 as AB square is equal to AD into AC. AB square we got here. And in statement number 2, we got BC square. Now, but we want addition of these two. We want AB square plus BC square. Now, left hand side of equation number 1 is AB square and left hand side of equation number 2 is BC square. Now, by adding these two, we will get this statement. Hence, adding 1 and 2. Adding 1 and 2, we will get AB square plus BC square. AB square plus BC square is equal to, means left hand side plus left hand side is equal to right hand side plus right hand side. That is AD into AC plus DC into AC. AD into AC plus DC into AC. Now on this side, what is common? That is AC. AC is common. Taking AC common. What is in bracket? That is AD plus DC. AD plus DC. By taking AC as common, we will get AC into bracket AD plus DC. Now observe this AD plus DC in diagram. AD plus DC is nothing but AC, since A dash here it will be A dash D dash C. AD plus DC is nothing but AC. Therefore, adding AD and DC will get this AC as it is into AD plus DC is AC again. That is equal to AC into AC, AC square. Therefore, I can write AC square is equal to AB square plus BC square. That was our target. That is AC square is equal to AB square plus BC square. This is about proof of Pythagoras theorem. See it once again. There is one right angle triangle, that is triangle ABC, which is right angled at point B. Means in triangle ABC, measure of angle ABC is 90 degree, and we have to prove the square of the hypotenuse. Square of the hypotenuse means AC square is equal to sum of squares of remaining two sides, that is AB square plus BC square. Now to prove this, we have constructed one segment, that is BD is perpendicular to hypotenuse AC. That is, draw segment BD perpendicular to hypotenuse AC, and A dash D dash C. A dash D dash C means point D is in between A and C. Now prove by using since this is right angle triangle there, and there is one altitude drawn on hypotenuse, therefore the two triangles are similar to the original triangle and similar to each other. Means all these three triangles are similar with each other. That is, triangle ABC is similar to triangle ADB, similar to triangle BDC. These names are important. Names should be perfect or correct. Then only these ratios will be correct. If the names are wrong, then ratios will also wrong. Now triangle AB, by taking this pair, that is triangle ABC is similar to triangle ADB. Since these two triangles are similar, therefore their corresponding sides are in proportion CSST. By taking two ratios containing one common side, that is AB, by taking first and third ratio, we will get AB square is equal to AD into AC. Statement number 1. Now by taking triangle ABC is common between these two pairs. Means in first pair triangle ABC is also there, in second pair also ABC is there. Means whole big triangle is common in these two, and the remaining triangle is that remaining one. Hence triangle ABC is similar to triangle BDC. By taking ratios corresponding sides in proportion, ratios of corresponding sides by using CSST, again by using two ratios which are having common side, that is BC, we will get BC square is equal to DC into AC. Statement number 2. But we want AB square plus BC square. Now here it is AB square, here it is BC square, and we want AB square plus BC square. Therefore adding 1 and 2, we will get AB square plus BC square is equal to AD into AC plus DC into AC. AD into AC plus DC into AC. Now in these two terms there is AC common, therefore taking it outside, I will get AD plus DC, but AD plus DC is nothing but AC again. Therefore AC this as it is into replacing this bracket by again AC, we will get AC into AC, that is AC square. Hence AC square is equal to AB square plus BC square. Means hypotenuse square is equal to sum of squares of remaining two sides. This is about Pythagoras theorem. Now we will move towards converse of Pythagoras theorem and its proof. Converse of Pythagoras theorem means interchanging given as to prove and to prove as given. We get converse. Converse in a triangle, in a triangle if the square of one side is equal to the sum of the squares of remaining two sides, then that triangle is then that triangle is, or then it is right angle triangle, then that triangle is right angled triangle. See statement of this converse. In a triangle, if the square of one side is equal to sum of squares of remaining two sides, means which was to prove in Pythagoras theorem. Now it is given, then that triangle is right angle triangle, which was given in Pythagoras theorem. Now it is to prove. Means interchanging given as to prove and to prove as given, we will get converse of Pythagoras theorem. For that I have to draw one diagram. Means there is one simple triangle, but it looks like right angle triangle, but we don't know it is right angled or not. We have to prove it as right angle triangle. Suppose triangle ABC. I am not going to write here symbol for right angle, since we have to prove this triangle as right angle triangle. Now it is not given. Now what is given? Simple one triangle is there. What is given? It is in a triangle, that is in triangle ABC. In triangle ABC, it is given if the square of one side is equal to the sum of squares of remaining two sides. This much is given. A from if up to then, this much is given. Square of one side, that first side will take as AC. Suppose AC square is equal to sum of squares of remaining two sides. AC square is equal to AB square plus BC square. AB square plus BC square, this is given. And what is to prove? What is to prove? That is the statement, part of the statement which comes after then. That is then that triangle is right angle triangle. Means we have to prove first side that we have considered as AC, therefore we have to prove the angle opposite to AC as right angle. Means we have to prove measure of angle ABC is equal to 90 degree. Means this means triangle ABC is right angle triangle. Means we have to prove this angle as 90 degree or right angle. And to prove this, we will do one construction. I am going to draw one more triangle which looks like this, that is triangle PQR, but which is right angle triangle. Triangle PQR, in which angle PQR is right angle and AB is congruent to PQ and BC is congruent to QR. The construction is like this. It is draw triangle PQR such that AB is congruent to PQ by taking this length for PQ, and BC is congruent to QR. And one more condition we have used here, that is angle PQR is equal to 90 degree, and measure of angle PQR is equal to 90 degree. Means we have drawn one right angle triangle like this one. This is not right angle triangle, we have to prove this as right angle triangle, but it looks like this one. AB is congruent to PQ and BC is congruent to QR, and this angle is right angle. Means this is one more triangle. Now the next part is to write proof. Now observe this triangle now, which is according to our construction, that is triangle PQR, that is in triangle PQR, which is right angle triangle. Hence we can use Pythagoras theorem here. By Pythagoras theorem, in triangle PQR, by using Pythagoras theorem, I can write now here side opposite to right angle is hypotenuse, therefore PR square is equal to PQ square plus QR square. PR square is equal to PQ square plus QR square. Now observe PQ square. Now PQ is nothing but PQ is congruent to AB according to our construction. Therefore, I can write PQ square as AB square, or I can replace PQ square by AB square. Therefore, replacing PQ square by AB square plus QR is congruent to BC. Therefore, replacing QR square by BC square. QR square by BC square. Reason construction. Reason is construction. Means we will get PR square is equal to AB square plus BC square, but AB square plus BC square according to given, AB square plus BC square is equal to AC square. Therefore, replacing AB square plus BC square by AC square, I can write replacing AB square plus BC square by AC square. Reason is given. Means we will get PR square is equal to AC square. Taking square roots on both sides, I can write PR is equal to AC. Suppose statement number 1. By taking square roots on both sides, we'll get PR square root of PR square is PR, square root of AC square is AC. Therefore, PR square is equal to, PR is equal to AC. Means PR is equal to AC. Now in these two triangles, that is in triangle ABC and triangle PQR, AB is congruent to PQ, which is according to construction. BC is congruent to QR, again construction, and AC is congruent to PR from statement number 1. AC is congruent to PR from statement number 1. Hence, triangle ABC is congruent, not similar, is congruent. It will be similar also. Triangle ABC is congruent to triangle PQR. I am going to write it directly, that is triangle ABC is congruent to triangle PQR by, ABC is congruent to triangle PQR by S and this one S test, that is S test. Triangle ABC is congruent to triangle PQR by S test, that is side test. Now, since these two triangles are congruent, hence their corresponding angles will be also congruent. And what are the remaining pair? Corresponding angles will be also congruent. But we want only one pair. Hence, angle ABC will be congruent to angle PQR. Hence, angle ABC is congruent to angle PQR. Reason, corresponding angles of congruent triangles. But measure of angle PQR, we have taken it as 90 degree. PQR is 90 degree. Therefore, ABC will be also 90 degree since both are congruent. Angle ABC, but measure of angle PQR is equal to 90 degree. Measure of angle PQR is 90 degree. Hence, measure of angle ABC is also 90 degree. This was our target, that is ABC is 90 degree. Hence, triangle ABC is a right angle triangle. Triangle ABC is a right angle triangle. See once again, what is given? There is one triangle given, that is triangle ABC. Now in triangle ABC, one relation is given about their side, that is square of one side is equal to sum of squares of remaining two sides, that is AC square is equal to AB square plus BC square. This is given, and we have to prove that first side we have considered as AC. Therefore, we have to prove the angle opposite to that first side, that is angle ABC is equal to 90 degree. Means we have to prove that triangle ABC is right angle triangle. For that, construction is very important. We have constructed one more triangle, that is triangle PQR, such that AB is congruent to PQ, BC is congruent to QR, and one more condition we have applied here, that is measure of angle PQR is equal to 90 degree. Now in this triangle, in this new triangle PQR, by using Pythagoras theorem, since angle PQR is right angle, we can use Pythagoras theorem, that is PR square is equal to PQ square plus QR square. Hypotenuse square is equal to sum of squares of remaining two sides. But PQ is equal to AB according to our construction. Therefore, we can replace PQ square by AB square. And QR is equal to BC. Therefore, we can replace QR square by BC square. Replacing QR square by BC square. This will get AB square plus BC square according to our construction. But AB square plus BC square AB square plus BC square is equal to AC square. Therefore, replacing AB square plus BC square by AC square, we will get PR square is equal to AC square. Taking square roots on both sides, we will get PR is equal to AC. Statement number 1. Now, in triangle ABC and triangle PQR, AB is congruent to PQ region construction, BC is congruent to QR region construction, and AC is congruent to PR region from 1. Hence, triangle ABC is congruent to triangle PQR. Triangle ABC is congruent to triangle PQR by SSS test. SSS test. Now, since these two triangles are congruent, therefore their corresponding angles are congruent. It is angle ABC is congruent to angle PQR. ABC is congruent to angle PQR region corresponding angles of congruent triangles. But measure of angle PQR we have constructed it as 90 degree, therefore ABC is also 90 degree. Means measure of angle ABC is 90 degree. That means triangle ABC is a right angled triangle. This is about converse of Pythagoras theorem. Now we'll move towards examples. It is practice set 2.1. We'll solve some examples from practice set 2.1. Practice it 2.1. We start with example number 1. There are various examples, or 6 or 7 examples in that. 6 examples are there. I will solve only one example, and remaining examples you can solve by using this method. Identify with reason. Identify with reason which of the following are Pythagorean triplet. Which of the following are Pythagorean triplet? There are 6 examples. I am going to solve 6th example. Suppose 11, 60 and 61. One triplet is given 11, 60 and 61, and we have to check it is Pythagorean triplet or not. Very simple. According to definition of Pythagorean triplet, if the square of the bigger number is equal to sum of squares of remaining 2 numbers, then it will be Pythagorean triplet. Now, out of these 3 numbers, square of bigger number is 61. Therefore, I'll take 61 square. That is equal to 3721. Now take squares of remaining 2 numbers, or take sum directly, that is 11 square plus 60 square. 11 square plus 60 square. 11 square is 121, 60 square is 3600. That is equal to 3721. And that is equal to 3721 means 61 square. Means square of bigger number is equal to sum of squares of remaining 2 numbers. Hence, this triplet, that is 11, 60 and 61, is a Pythagorean triplet. Hence, 11, 60 and 61 is a Pythagorean triplet. See once again. There is one triplet given. We will consider as square of bigger number, that is 61 square, as simply 61 into 61, that is 3721. Takes the sum of squares of remaining 2 numbers, and that also we will get as 3721. That is equal to square of the bigger number. Means we will get 61 square is equal to 11 square plus 60 square. Hence, 11, 60 and 61 is a Pythagorean triplet. If it is not equal, suppose this sum is not equal to bigger number, then it will be like this. It is not equal to 61 square. Hence answer will be is not a Pythagorean triplet. Is not a Pythagorean triplet means we have to identify, we have to check it is Pythagorean triplet or not. It is not compulsory that it will be Pythagorean triplet. Now here it is Pythagorean triplet, but it is if it is not equal, then we have to change it like change that answer like this. You have to write first square of bigger number, then take sum of squares of remaining two numbers. Both answers will be there. Suppose this answer is different, then it will not be equal to this one. Then answer will be that triplet is not a Pythagorean triplet. Answer will be like this. Pattern is same. So all remaining examples also. Then we move towards example number 2. One diagram is given. This triangle MNP is given, which is right angled at point N. MNP and one altitude is drawn on hypotenuse, that is NQ, is perpendicular to NMP. MQ is given as 9. QP is given as 4. And find NQ. Find NQ. I am not going to write question here again. In diagram all the information is given. Triangle MNP is right angled at point N. NQ is perpendicular to NP. NQ is given as 9. QP is given as 4. And we want NQ. Very simple. By using theorem of geometric mean. This is perpendicular drawn from opposite vertex on hypotenuse. Drawn on hypotenuse from its opposite vertex, and it is geometric mean of the segments formed because of that perpendicular segments or parts of the hypotenuse because of that perpendicular. Means NQ is geometric mean of MQ and QP by using previously proved theorem that we have proved during yesterday's live session, that is by theorem of geometric mean. By theorem of geometric mean, I can write NQ square is equal to MQ into QP. NQ square is equal to MQ into QP. Very simple. NQ square is equal to MQ is given as 9. QP is given as 4. 9 into 4, that is 36. NQ square is 36. Taking square roots on both sides, we will get NQ is equal to square root of 36, that is 6 units. If we get NQ is 6 units. See once again, there is one right angle triangle MNP and NQ is perpendicular to NP, and we want NQ by using previously proved theorem, that is theorem of geometric mean. I can write NQ square is equal to MQ into QP. NQ square is equal to 9 into 4, that is 36. Therefore, by taking square roots, we will get NQ as 6. Take screenshot if you want, and we'll move towards next, that is example number 4. I'll skip example number 3 that we can solve, and I'm going to write example number 4. One diagram is given again. There is one right angle triangle. It is triangle PSR, which is right angled at point S. One angle, this second angle is given as 30 degree. SR is given as 6. Find RP and PS. Find RP and PS. Now there is again right angle triangle, but one more angle is given as 30 degree. Therefore remaining angle will be 60 degree. This is 90 plus 30, that is 120, 180 minus 120, that is 60 degree. Hence I am going to write this angle first, that is major angle or in triangle PSR. Major angle SRP is equal to 60 degree. Reason remaining angle of triangle. The sum of measures of all the three angles is 180. By subtracting 90 and 30 from 180, we will get this angle as 60 degree. Hence triangle PSR is 30, 60, 90 degree triangle. Hence by 30, 60, 90 degree triangle property or triangle theorem that we have learned yesterday. We have seen just the statement of that theorem. Proof we have learned in previous year. By 30, 60, 90 degree triangle theorem, side opposite to 30 degree is half of hypotenuse. Side opposite to 30 degree is half of hypotenuse. Means I can write side opposite to 30 degree means SR is equal to half of hypotenuse, that is RP. SR is equal to half of RP. But SR is given as 6, therefore 6 is equal to half of RP. Taking 2 this side, we will get RP is equal to 6 into 2, that is 12. RP is equal to 12. We got RP. Now we want PS. PS is nothing but side opposite to 60 degree. This angle is 60 degree. Now side opposite to 60 degrees, that is SP is equal to root 3 by 2 times hypotenuse, that is RP. SP is equal to root 3 by 2 times RP. RP is 12. Therefore root 3 by 2 into 12. Therefore we will get SP is equal to 6 root 3 means PS. SP means PS is equal to 6 root 3. See once again, there is one triangle given, one angle as 90 degree, another angle is 30 degree. Therefore remaining angle of the triangle will be 60 degree, means triangle PSR is 30, 60, 90 degree triangle. Hence by using 30, 60, 90 degree triangle theorem, we will get side opposite to 30 degree is half of hypotenuse, that is, but side opposite to 30 degree is given. 6 is equal to half of RP, therefore we will get RP, that is hypotenuse, as 12. Now side opposite to 60 degrees, root 3 by 2 times hypotenuse, that is root 3 by 2 into RP means 12, that is equal to 6 root 3. SP means PS is equal to 6 root 3. It's about example number 4. Then we'll move towards example number 6. If you want screenshot, then take. Example number 6. Find the side and perimeter of a square find the side and perimeter of a square whose diagonal is 10 centimeter, whose diagonal is 10 centimeter. Diagram is not given, we have to draw a proper diagram. Means we have to draw square. Suppose square ABCD. Square means all the 4 sides are congruent, all the 4 angles are right angles or congruent. Suppose quadrilateral ABCD is a square in which AB is congruent to BC is congruent to DC is congruent to AD, and all the four angles are right angles. This is square. Now we want side and perimeter of a square whose diagonal is given. There are two diagonals and both will be congruent. We'll draw one diagonal simply. That is, diagonal is given as 10. Suppose AC is given as 10 centimeter, and we want side and perimeter. If you can find side, then perimeter will be addition of all the four sides. Suppose side of this square is x, means AB is x, BC is also x, DC will be also x, and AD will be also x. Now observe this triangle, which is obviously triangle ABC is right angle triangle. Now solution: let AB is equal to BC is equal to CD is equal to AD is equal to x. Quadrilateral ABCD is square in which all the four sides are x. Now in right angle triangle ABC, by Pythagoras theorem, in right angle triangle ABC, by Pythagoras theorem, I can write AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. But AC is given as 10, therefore 10 square is equal to AB is x, BC is also x, that is x square plus x square. Therefore we will get 100 is equal to x square plus x square is 2x square. Taking 2 this side, that is 100 upon 2, that is x square. Upon 2, that is x square. Therefore 100 upon 2 means 50. Therefore x square is equal to 50. Therefore x is equal to root 50. X is equal to root 50, and that is equal to square root of 25 into 2, that is 5 root 2. Therefore we will get x as 5 root 2. X is equal to 5 root 2. This side of square is equal to side of square is equal to 5 root 2 centimeter. Now we want perimeter of square. So perimeter of square is equal to 4 into side, that is 4 into 5 root 2, that is 20 root 2 centimeter. Perimeter will be 20 root 2 centimeter. See once again, there is one square which diagram is not given, but we have drawn one square, that is square ABCD, in which all the four sides we have considered as x, and there is one diagonal which is given as 10. Therefore in triangle ABC, which is right angle triangle, we can use Pythagoras theorem, that is AC square is equal to AB square plus BC square. Putting value of AC, will get x square as 50. Therefore x is equal to 5 root 2. Now side of square is 5 root 2. Now perimeter will be sum of squares of all the four sides, means 4 into side, that is 4 into 5 root 2, that is 20 root 2 centimeter. Take screenshot. We'll solve example number 7 and then we'll stop. Example number 7 from practice set 1.2. There is one triangle given, that is triangle DEF. in triangle DEF, in which angle F is 90 degree and perpendicular is drawn from F on hypotenuse. This is perpendicular. Suppose FG is perpendicular to DE. GD is given as 8. GF is given as 12. And we have to find number 1 EG, number 2 FD, and number 3 EF. See, what is given? There is one right angle triangle, that is DFE, which is right angle at point F, means measure of angle DF is 90 degree. FG is perpendicular to ED. GD is given as 8. GD is given as 8. GF is given as 12, and we want EG, FD, and EF. We want lengths of these three sides, EG, FD, and EF. We start solution. Now first we will find EG. For that, observe this triangle, which is right angle, and this is perpendicular drawn on hypotenuse from its opposite vertex. Hence, by theorem of geometric mean, I can write FG square is equal to EG into GD. FG square is equal to EG into GD. FG square is equal to EG into GD by theorem of geometric mean. But FG is given as 12. Therefore, 12 square is equal to EG we have to find into GD is given as 8. 12 square is 144 is equal to EG into 8. Therefore, we will get EG is equal to 144 by 8. Therefore, EG is equal to 18. EG is equal to 18. 144 by 8. Therefore, we get EG is equal to 18. This we have got EG. Now we want FD and EF. To find FD, use this triangle, which is right angle triangle. We can use Pythagoras theorem. And to find EF, we can use this triangle. By using Pythagoras theorem, we can find EF. We will find DF first, that is in right angle triangle. GDF by Pythagoras theorem. By Pythagoras theorem, hypotenuse square, that is DF square, is equal to sum of squares of remaining two sides, that is GD square plus GF square. GD square plus GF square. That is equal to GD square is 8 square plus GF is 12. That is equal to 8 square is 64 plus 12 square is 144. That is equal to 208. Therefore, DF is equal to square root of 208. That is equal to square root of 16 into 13. That is 4 root 13. Similarly, in right angle triangle, this one EGF, I am going to write directly. In right angle triangle EGF, by Pythagoras theorem, I can write EF square is equal to EG square plus GF square. EF square is equal to EG square plus GF square. These two lines will be there in right angle triangle EGF. Again, by Pythagoras theorem, we will get this one. Now putting values, that is EF square is equal to EG square. EG is 18. 18 square plus GF is 12. 18 square is 324 plus 12 square is 144, that is equal to 468. Therefore, EF is equal to square root of 468, that is equal to 36 into 13. Therefore, EF is equal to 6 root 13. EF is equal to 6 root 13 and DF is equal to 4 root 13. See once again, there is one right angle triangle DFE in which angle F is right angle, and there is one perpendicular altitude on hypotenuse, that is GF is or FG is perpendicular to ED, and two values are given and we want three values. Now in this triangle, by theorem of geometric mean, we will get FG square is equal to EG into GD. By calculation we will get EG as 18. Now in right angle triangle, this one, that is DG or GDF, by Pythagoras theorem we will get DF as square root of 208. This is also correct and this is also correct. Both answers are correct. You can stop here also. But by calculation or by splitting this 208 will as 16 into 13, taking 16 outside, we will get DF as 4 root 13. Similarly, in this right angle triangle we will get, again by Pythagoras theorem, we will get EF as 6 root 13. It's about solution of example number 7. Remaining examples will solve tomorrow or during next live session. We'll stop here. Thank you.